Hello, ladies and gentlemen. My name is Kurt, and welcome to NASA Eyes on the Solar System. This is the Solar System 3D web app that NASA has set up, where you can check out a whole bunch of different spacecraft and solar system objects within your very web browser you're using to watch this video now, perhaps. It's the same program that we used during my Curiosity Landing on Mars livestream on Twitch TV. But today we're in for a little bit more of a natural flyby, an encounter if you will, that is of Asteroid 2012 DA14. We are looking at it right now. It's right here on the bottom of the screen, and we are looking at what Earth looks like if you were just kind of hovering above the asteroid, about 22 hours out from the closest approach. And let me look up my notes here. The closest approach is going to be tomorrow, Friday, February 15th, at 1930 Universal Time, which equates to, if you're in the US here, 2:30 p.m. Eastern Standard Time. So middle of the day for us, which means it's going to pass by on the nighttime side of Earth, and the best views are actually going to be coming from Asia, Australia, and Eastern Europe. So unfortunately, we don't really luck out in being able to see this object during its closest approach, but it's still a cool thing to look at, and you can actually look at it through Eyes on the Solar System. I'll put a link in the doobly-doo for it. First of all, let me just specify once again that there is no chance at all, of this asteroid impacting the Earth. It is going to pass at its closest 27,000 kilometers away, which is no small thing indeed. It's going to be closer than our geosynchronous satellites, well within the orbit of the moon as well. And I can actually show that by zooming out. Up. Oh, I'm on the right along. Let's go to the live overview. Here we go. Whoa! Here we can see all of the planets in the solar system: Sun, Mercury, Venus, Mars way out there. We've got the Spitzer Space Telescope, Kepler Telescope, kind of orbiting in a trailing behind the Earth orbit, kind of cool. But then up much closer, we have the Asteroid and a whole bunch of other orbiting scientific satellites. These aren't necessarily geosynchronous satellites. These are just NASA satellites. The geosynchronous satellites are all the commercial, your GPS satellites, your communication satellites that need to be specifically over the top of a certain section of the Earth and orbiting at the same speed that the Earth is rotating. But let me actually bring up the menu here and disable these spacecraft, because they're a little bit cluttering. Let's get the moon back. Never heard that before. There we go. There's the moon. There's the orbit of the moon. So the asteroid is actually going to be coming from the south. It's not going to be like shooting in from the outside of the solar system out of nowhere, or smacking in the opposite direction or anything like that. It's actually on a very similar orbit around the sun as the Earth, just on a slightly different ecliptic plane, which makes it seem like it's aimed right at us in the south, but that's just really the relative motion to the Earth. Let's go back to our ride-along view. Woo! And let's experience the flyby as if we were the asteroid. So here we go. I'm going to speed up time. As you can see, we're coming down on 20 hours. It's kind of an interesting experience. There's no chance, by the way, of the asteroid interfering with or impacting any satellites, simply because there's so much space out there. It's not like, I'm sure a lot of you probably saw WALL-E or other such space movies where space junk is just like an entire layer of satellites bouncing into each other and things like that. It's not like that at all. There's so much, the human brain cannot possibly comprehend how much space there is out here, how small necessarily our Earth is, and how small of a target it would be for this asteroid to even hit the Earth, but also how small then the satellites are compared to. There's no chance, they've said there's no chance that this asteroid will impact any satellites or cause any issues like that. So as you can see, we are now, what is the time? It is, speaking in terms of Central Time, February 15th, 1:21 p.m. Central Time, which equates to 2:21 p.m. Eastern Time. But as you can see, it's going to pass on the nighttime side, and there's Australia, there's Asia, and there's kind of Eastern Europe is going to get a little bit of a view. It's going to be difficult. But if you are in these areas, you can check it out with your own eyes with the help of at least binoculars, potentially a telescope. Telescope might be a little more difficult than binoculars, because binoculars you can move around however fast you need them to. Telescopes you need to kind of point at a portion of the sky that you know the asteroid is going to pass through and kind of sit there and wait for the little light to pass by. And I've been told you can look that sort of very specific information up at heavensabove.com. For those of us not fortunate enough to be on this side of the planet, in order to see this fly by ourselves, there are going to be a bunch of live streams. NASA JPL, for one, is going to be live streaming with telescopes that they have in Australia and Europe, starting at noon, 12 noon Eastern Standard Time. So you can check that out. They're obviously going to have a lot of scientists and other NASA people talking and guiding us through what we're looking at. To be honest, it's not going to be all that spectacular. The way an asteroid, even a 50 meters wide asteroid, is going to look, it's going to be it's going to look like a star, a very slowly moving star. If it is tumbling, then we might get some of the different refracting shine of the sunlight off of the asteroid, which is sometimes interesting. I've actually been able to see that with, I've accidentally caught through my eyepiece, looking through my telescope, one of those kind of strange lights that's kind of blinking on and off out there, but it turns out that sort of thing is actually either a satellite that's tumbling or a used rocket body that's just left in orbit, actual space debris. And every time it tumbles, it catches the light from the sun a different way, and it kind of makes the light dimmer and brighter. And you can notice that through, it starts to become quite synchronous, and okay, it's very predictable. So that object out there is tumbling. So that, at the most, is what we're going to be able to see. They do have radio telescopes aimed at this that will give us a much better picture than any optical telescope would be able to, as to the general shape, the mass and size of the object. This, what we're looking at right now, is an estimation, a very generic representation. Okay, an asteroid is a rocky gray object. So this is what NASA has put in their Eyes on the Solar System program. So just an approximation. This isn't exactly what the asteroid looks like, but if I just increase the speed once again, we'll see. Going to have a nice flyby, and already we're passing away onwards and outwards through the north there, and eventually, if I zoom out, if I can zoom out, I can't really zoom out. Hello, whoa, hello, yep, there's this. Okay, there's the moon. So it's not, the moon isn't in any danger or anything like that. Don't worry about that. And obviously, you look at the moon, it's been hit by much larger objects than this, so it's all right. So yeah, kind of a non-event, but it's an event. It would have been cool, I guess, if we had been investing in our space programs enough and being a little bit more bold with our missions. This would have been a perfect, maybe not, I don't know, I'm not a scientist, but it seems like it would have been a perfect opportunity to send perhaps a robotic mission. You know, why we're sending actually robotic missions out deep into the solar system to explore comets and asteroids that we know are out there. The universe basically delivered this one to our front step. It would be a lot easier to get to and explore. Eventually, NASA are saying that they would plan, before heading to Mars, certain missions to near-Earth asteroids, perhaps similar to this, or perhaps a little bit larger but further out. I'm sure it gets a little bit complicated the closer you get to Earth, because then Earth's gravity will end up bending the trajectory of the asteroid and make it a little bit unpredictable, but it would have been nice. But as the quote goes, asteroids are the universe's way of asking, how's that space program coming along? Because the more that we learn about these things and the more of them that we find, the more we can protect ourselves from potential impacts and learn ways to deflect things like this. But also, These do kind of geologically and what they're composed of gives us a look into the history of where our solar system came from and what formed the planets, like Earth, and perhaps the pre-solar grains. Where did all this material come from? What are the supernova remnants and previous generation of stars that exploded and gave their denser materials to create things like the Earth and these asteroids and our sun and whatnot, and indeed, and etc. So it's all scientifically relevant and awesome indeed. Like I said, I'll remember to put those links in the video description to both Eyes on the Solar System, so you can check this out and mess around with it on yourself, and also to the NASA JPL live stream website, so you can check that out. Let me look down my notes really quick, just to make sure I haven't missed anything. Nope, I think we've got it all there, so thank you once again for watching and sharing my interests in the solar system and astronomy and space. We're safe for now. This is a close shave, but it's no worrisome impact risk or anything like that. Just take some time and enjoy tomorrow and the next day until something like this happens again. Then you might have to worry. No, just kidding. I'm a jerk. Anyway, this jerk's name is Kurt. Thanks so much for watching. I will see you next time.